so here's the recording of 33 from section 4.1. If we're going to do an exploration of extreme values for a function, it's helpful to know about the critical values of the function. Do we have any idea what the critical values of this function are? Do we have any idea what the expression critical values or critical point means? Okay, Edmund, you're nodding, so tell me please, what does it mean to be a critical point?
When the derivative of h of x is equal to 0.
Okay, so critical points when h prime of x equal to 0, or louder,
Does not exist.
or h prime dne does not exist. Any ideas?
Find the derivative.
Find the derivative. To find the derivative of this is hard.
I didn't mean to ask that. What do you do with absolute functions?
And the answer is, what do we do with them? What we do with them is we treat them like the piecewise functions that they are. Okay? Meaning, the absolute value of x is a piecewise function. It's equal to negative x when x is less than or equal to 0. It's equal to this, the plain old value of x is if x is greater than 0. Inherent into the absolute value function is this piecewise nature. I want to rewrite this problem piecewise. And it's not going to be fun. Then why do it? Well, because I don't know of any other way to get to the answer. Do they say that we must use analytic methods?
No, because I just grabbed it.
Because if we just graph it, can't we just read the extreme values off the graph? Do they say we can't graph it?
No. It does, it specifically says that for one part, but it doesn't say it for this part, so I said because it didn't say it, you might as well use your calculator.
How do they treat it in the back? They just say where the extreme values are, aren't they? Oh, it feels like cheating.
But it's not
Well, we should
cheating.
still do the
You're
derivative.
You're
taking
taking
advantage
advantage
of our
of
Well, I'm just saying, because the derivative of this, I mean, simply just rewriting this in piecewise form is hard. I mean, the piecewise version of this looks something like, it's going to be in 3 parts. If we are lower than negative 2, if x is lower than negative 2, why am I choosing negative 2? Because that's the boundary where this absolute value switches from the positive to negative. If we're lower than negative 2, we've got the opposite of x plus 2 minus the opposite of x minus 3. Yeeks.
See, I wouldn't even know that. I would forget. Like, how do you not know how to do it?
Can we just add?
Okay. Let's go through that idea. When we get really big negative numbers in here, this expression is negative. How do I do the negative expression to make it the positive absolute value that we know and love? We take the opposite of it. So when we got really big negative numbers, and those really big numbers start at being less than 2, I have to take this expression and take the opposite of it. I'm doing just like we said in the definition of absolute value. I'm taking the opposite of it. When I've got really big negative numbers, this expression is negative as well. So I'm going to write the negative of that expression.
Can we just add x minus 3? Or
Now that ends up netting out to an add. That's
Okay.
true. But that's what we end up with. Okay. By the way, this expression cleans up a little bit. This expression cleans up a lot. I get a negative x and a positive x.
So it's just a
The negative x and the positive x equals 0. I got a negative 2 and a negative 3. I get a negative 5. Anthony, when you graphed it, did you get a negative 5?
Yeah, for the absolute number.
Okay. Now, what about in between? Sorry, that's smaller than negative 2. What about in between negative 2 and positive 3? Do I have to find the opposite of that expression again? No, that expression is now positive. It is just what it is. X plus 2. What about here? When I'm less than 3, this expression is negative, and I'm going to need the, again, opposite of, the opposite of that expression. And as you noted before, those two clean up, and then what do we get? 2x minus 2x minus 1. And then lastly, what happens when x is greater than 3? X plus 2 minus x, minus the quantity x minus 3. The x's cancel, and we get positive 5. So what I think this graph looks like is negative 5, and then it's got a slope upward, and then it goes to positive 5. And Anthony, when you graphed it on your calculator, did you get something that looked like that? Yeah, Nicole? Did I cancel out the x's before I...
Or you mean, because wasn't there x plus 2 minus x minus 2, or was it?
No, it was x plus 2 minus the quantity x minus 3. So what I did was I distributed that negative sign through. I get a negative x and a positive x. They go kaplooey. I get a 2 plus a 3 to get the 5. Alright? So from this graph, what do we get?
And that's just our original function, we still haven't taken the derivative yet?
You know, the more I do this, the more I think Anthony's right.
Just use the calculator?
No, it's like, well, once we get the graph, do we really need any more evidence to suggest that the absolute minimum is 5, or negative 5? Do we need to do any more work than looking at that graph and saying, oh, the absolute maximum is 5? But if you're a glutton for punishment, here's the derivative function. Oops. Fatal flaw. Well, not fatal.
I have a question.
Let me finish, mess. That was fun. I hope it doesn't do that again.
Where are they supposed to be less than or greater than, or like equal to? Because your signs are different everywhere.
This is when x is less than negative 2.
Yeah, but over there you have it's less than or equal to. Is one of those?
Well,
wrong?
this is the derivative function.
Okay. Is it?
The derivative function.
And you have
Why
coordinates.
didn't I include?
Because it doesn't exist corners.
Because these are corners. So what do we know about the derivatives at those places?
They don't exist.
They don't exist. So my derivative function recognizes that.
Okay.
So normally I'd say, oh, I made a mistake. But no, I actually did that purposefully. Okay, so there's what? What was that? 33? Yeah. All right. What else do you want? Should we say that?
Oh, I have a question.
Yeah.
What is the correct way to say what the absolute minimum of
Okay. In this problem, we would say, maybe you should even write it. The absolute max is 5.
Okay, you don't have to say like,
We don't have to say where it is. All we have to say what it is. And it's the absolute max and the absolute min are y values.
okay,
The absolute min is negative 5.
so if we put it as an ordered pair, that's incorrect. It should only
That
should
it-
just be the y value.
Yes, it would be incorrect to say the absolute minimum is negative 3, negative 5.
Okay,
The absolute max and the absolute min are only the y values. We may use the expression the location of the absolute max or the location of the absolute min is.
gotcha.
Okay. And then that's when we would present the x values.
Okay.
All right. So that's 33.